Okay, physical properties of alcohols. Name two physical properties of alcohols. Just to save some time, I wrote this out or typed this up previously. So the first is the boiling point of alcohols is higher than for alkanes of similar molecular mass. So if you have, for instance, methanol, and I could put methane, but because that oxygen is pretty heavy, so have something like ethane. It would be on the same order. Or propane. Propane is a gas at room temperature. Methanol is a liquid. Butane is a gas at room temperature, where methanol is a liquid. And so alcohols, because of that OH group, we will get these molecules that are very small that still are liquid at room temperature. And then the second physical property, the solubility of alcohols decreases, so I should say solubility in water, or wherever it should go in there. Solubility of alcohols in water decreases as the chain, carbon chain length increases. So let's take a look at why that is. So those are the two properties. Now if I asked you why, we have those types of physical properties. The answer is it's due to hydrogen bonding. Here, should have used different colors here, but here's methanol. And you can see that it has that OH group, and just like water, which has an OH group, it has the oxygen is slightly negative, the hydrogen is slightly positive, so any other methanol can come in here. The hydrogen from this methanol, this OH group on this methanol, will be attracted to this oxygen on another methanol. Third methanol can come in here as well, and you create this network of hydrogen bonding across all of the methanols that are present in your system. And the hydrogen bond is about 1/10 the strength of a covalent bond, but covalent bonds are very, very strong, so even 1/10 is a pretty strong bond. And to get these molecules to go into the gas phase, you have to break those bonds. Well, at the room temperature, even for the smallest alcohol, which is methanol, and still requires a lot of energy to get it to go into the gas phase. So they're volatile, definitely. If you pour methanol onto your hand, you'll note that it will evaporate very, very quickly. You pour it on the table, at room temperature, anywhere where it's room temperature, it will evaporate very quickly, but it still starts out as a liquid. As far as the solubility, we have methanol here. We had hydrogen bonding to itself, but it can also hydrogen bond to water. It's also, this side is also polar, which is going to be dragging the methanol into water, but that hydrogen bonding really helps as well. Now here's the polar side of the molecule, the one that will hydrogen bond, and this side is the non-polar side. And they're about even Steven, so the water has a lot of the methanol molecule that it can work with, that it's attracted to. So methanol is completely miscible in water. You can usually described as you can take a cup of methanol and pour it into a swimming pool of water and it will mix. You can also take a cup of water and pour it into a swimming pool of methanol, and it will mix. So any amount of these two compounds will mix completely. They're both completely soluble in one another. But if we extend the chain, as we can do, we can go to methanol. Ethanol is completely miscible, and then propanol, butanol, we keep going. As we get a larger amount of this nonpolar side, well, when you put butanol into water, it is slightly soluble. It's not completely soluble, just slightly soluble, because the water has only this part, this small part of the molecule to be attracted to. When water molecules come over to this nonpolar side, they have no idea what to do with this. They have no interaction with this side. And so what this OH group has to do is pull this whole molecule into solution. It does it to a small amount. But the longer this chain, the smaller the percentage of the molecule that is polar and capable of hydrogen bonding. So we can see that as we keep adding in this nonpolar chain, eventually if we had 20 carbons on here, it's almost the same thing as having a 20 carbon alkane. There's just this little tiny hydroxyl group on the end. So though there would be a difference in solubility, that molecule would definitely go into water to a slight amount, much more so than the 20 carbon alkane.